So let's talk about a weapon that isn't about bombs or bullets. We're going to dive into a weapon that targets the very technology our modern world is built on. It's a silent, invisible force, but it has the power to unleash absolute chaos.
Just take a second to really think about that. A single attack that could paralyze an entire country, bringing everything to a dead stop in the blink of an eye.
And that's the kicker, right? This isn't about explosions or rubble. It's about flipping the off switch on a whole civilization. This is the truly unique and, honestly, kind of terrifying threat of an electromagnetic pulse, or what we call an EMP.
Now, this might sound like something straight out of a sci-fi movie, but the reality of EMP is totally grounded in real-world history. Its discovery, which came right out of the nuclear age, completely changed the way we think about strategic threats. You know, we first stumbled onto this idea during high-altitude nuclear tests. Back in 1962, the Starfish Prime test set off a nuke way up above the Pacific. And the result? Streetlights in Hawaii started blowing out, and phone systems just died. And Hawaii was almost 1,400 kilometers away. Then we saw a natural version of this in 1989, when a massive solar storm, basically a natural EMP, knocked out power for 6 million people in Quebec. These events proved it. A powerful burst of energy could absolutely wreck technology from a huge distance.
So how does that even work? How can an invisible pulse of energy physically destroy solid electronics? Well, the science behind this silent killer is pretty wild. An EMP is, well, it's exactly what it sounds like. It's a massive but super short blast of electromagnetic energy. We're not talking about heat or radiation like you might think. This is a pure wave of electric and magnetic force.
And the whole process is unbelievably fast. First, the pulse creates this intense electromagnetic field. This field then hits any conductive material, and I mean everything, every wire, every antenna, even the tiny little metal lines on a circuit board. It induces this massive, out-of-control electrical current. This surge is way more than the electronics were ever built to handle, and in a split second, all the sensitive microchips and transistors are just overwhelmed and permanently destroyed. They literally get fried from the inside out.
And this right here, this is the perfect way to picture it. You know how we all use surge protectors for our computers? An EMP is like a continent-sized power surge that doesn't even need wires. It just flies right through the air to get to your devices.
This shows you the great irony of all our technological progress. Our modern, super sophisticated electronics, our phones, our computers, the systems that run our cars, they're all incredibly vulnerable because they use these delicate, low-voltage circuits. But an older, simpler machine like a classic car from the 50s with 0 computer chips or even just a basic light switch, it's much tougher. It'd take a way more powerful pulse to affect it. Our own advancement has actually made us more fragile.
So, look. The critical thing to understand isn't just about your phone or laptop dying. It's about what happens when millions of essential systems all fail at the exact same time. This is where you get the potential for a total, cascading collapse of our interconnected world. This quote from the Congressional EMP Commission report just nails it. Our world isn't a bunch of separate pieces, it's a system of systems. Everything depends on everything else to work. And these are the pillars holding that system up. The power grid, that's the big one. It's the master system. If you can take out the grid, you don't even need to worry about the others. Because without power, telecommunications go dark. Without power and communications, banking stops. Fuel can't be transported, water treatment plants shut down, and even emergency services can't function. It's a chain reaction.
Okay, let's look at a real example. This chart shows you all the things the oil industry depends on. You see, it's not just about the oil itself. It needs electricity to run the pumps, telecom for the control systems, banking to handle the money, and roads just to get repair crews out to a site. An EMP doesn't have to hit the oil rig, it just has to hit the power grid that the rig needs to function.
And it's the exact same story for natural gas. You see that same tangled web of dependencies? You just have to knock out 1 or 2 of those key nodes, like electricity and telecom, and the whole system just starts to unravel. That's the textbook definition of a cascading failure.
Now, the electronic brain behind all of this stuff is something called SCADA. These are the computer systems that let a handful of people monitor and control these enormous infrastructures from one central place. They're basically the nervous system of our modern world. But because they're electronic and spread out all over the country, they are a massive vulnerability in an EMP attack.
To really bring this home, think about this number. Back in 2003, there were over 371,000 ATMs in the U.S. Every single one of them needs the power grid to turn on and the telecom network to talk to the bank. In an EMP scenario, it's not just that the financial system gets disrupted, your access to physical cash could literally vanish in an instant.
All right, so after hearing all of that, the obvious question is, are we just totally helpless? Is there anything at all we can do to protect our digital world? Well, thankfully, the answer is yes. Protection is actually possible.
So the strategy is all about layered defense. It starts with the strongest method, isolation. This basically means putting your most critical electronics inside a Faraday cage, which is really just a metal box, that physically blocks the pulse. Then, for any wires that have to go to the outside world, you install special filters and heavy-duty surge protectors to stop the pulse from coming down the line. And finally, you can build shielding like copper mesh directly into buildings and equipment to create a final barrier.
And this isn't just theory. The military and critical government facilities have been hardening their sites against EMPs for decades. We know how to do this. The methods work. The real challenge isn't the technology. It's the unbelievable scale and cost of trying to apply these protections to our massive civilian infrastructure.
Which all leaves us with one final, pretty sobering question. We live in an age that is completely defined by our technology, by being connected. And in a world like this, maybe the most powerful weapon of all isn't one that levels a city, but one that just turns it off, leaving behind no visible trace, just a deafening digital silence.